Okay, so in this video we're going to do essentially the same thing as in the previous video, except now the outer function is going to be an exponential function. And actually the exponential function is going to be the special one, the one with base e. Okay, so again we're just applying the chain rule to a composition of functions where the outer function, okay, that's this function I've circled here in orange, is an exponential function. And let's go ahead and move right into an example. So here is e to the 5x plus 2. You know that the derivative of e to the x is itself. So how is this going to go? It's just going to go, the derivative of e to the 5x plus 2 is going to be itself times what? Well, the thing you plugged into e to the x was 5x plus 2, so what's the chain? It'll be the derivative of 5x plus 2, which is simply 5 plus 0. And so you see, the final answer is e to the 5x plus 2 times 5. Exactly how it was like in the first chain rule video, where we said e to the, for example, the derivative of e to the 5x was itself times a little bit of extra. And so you see that little bit of extra is right here, and you can see it comes out just from the chain rule. You don't have to do any fancy things with the exponential, like we did in that one of those other videos. Okay, so let's move on to another example. Here is e to the power x plus square root of x, and that whole thing squared. All right, so it's like e to a power, but it's fine because we know that the thing we're plugging into is e to the x. So we know what the outer function is. The inner function is just some power function essentially. So, but it turns out we're going to have to use chain rule twice, and you'll see how this goes. So how does this? How are we going to do this? E to something squared, the derivative of that is going to be itself times, well, the chain of that. So what's the derivative of that? It's going to be 2 times x plus square root of x to the power 1. That's just the power rule for the thing in the exponent. But remember, there was something else there too, so let me just draw the chain. There's another chain that comes from what was inside the square. So the derivative of that is going to be 1 plus, well, the derivative of 1/2 of x to the 1/2 is 1/2 x to the minus 1/2. And there you go. So let me just clean this up a bit. The derivative is e to the x plus square root of x, that quantity squared, times 2x plus square root of x, whoops, x plus square root of x, times 1 plus, and I'll just rewrite this the way we did in a previous video, square root of x over x. And remember how that trick goes. If x to the minus 1 over 2 is equal to 1 over square root of x, then what you do is you multiply the top and the bottom by square root of x. All right, so that's just that little thing that went on right here. Anyway, here is the final answer. All right, it looks complicated, but you see the sequence goes in a very well-defined order, or the order in which you do things is very well-defined. So let's go on to another example. This time we're plugging in not only a power function into an exponential function, but another exponential function. So let's try to keep this straight in our heads. What's the derivative of e to something? It's always going to be itself. But now you have to chain what you plugged in. So what's the derivative of x squared plus 2 to the x? It'll be 2x plus, well, 2 to the power x is another exponential function, so it's going to be itself times ln of the base, which is 2. All right, so the final answer is just to write it without any of the squiggly marks. It'll be e to the x squared plus 2x times the quantity 2x plus 2 to the power x times ln 2. Notice how I'm very careful with my parentheses. Of course, if you plug in a value for a particular value for x, having those parentheses there will be very important. Okay, let's do another example. Oh, actually, for this last example, this is a sort of special one. Remember we had the formula for the derivative of log. So and in that video I just gave you the formula. Well, my claim now is, now if you assume that you know the derivative for the exponential function, and if you know the chain rule, then you can actually derive this formula just by knowing those two facts. All right, how's this going to go? So let's just recall that log and e to the x are inverses of each other. In what way though? In this way. So we know that when you take e and you raise it to the ln x power, you actually just get x back. Okay? So now let's take the derivative of both sides. So we take the derivative of both sides, and what do you get? Well, what's the derivative of e to the ln x? That's just going to be itself times the derivative of what you plugged in to the exponential function. That's that's the derivative of ln x. That's the thing that we want, right? So I'm trying to derive the formula. I want to know why it should be 1 over x. Well, check this out. Look on the right-hand side of the equation. What's the derivative of x with respect to x? That's just 1 by the power rule. And if you know, because e to the ln x is always equal to x, that was just from this part right here, we know that what we really have for now is x times d dx ln x equals 1. And so finally we have that d dx ln x, so that's the thing we're solving for, that's equal to 1 over x. See? So not bad. All we really needed to know to derive that formula was the derivative of the exponential function and the chain rule. Okay, and that is all. In the last video, we are going to go do this. We're going to do one more video with the chain rule, except the outer function is going to be a log.